Okay, so today, let's see, Math 2A. It is Wednesday. Hallelujah. 10/6/21. And what are we doing? Let's review factoring polynomials. And we're in our um, language, how we've been talking about them. These are the harder ones. These are the ones when A is not 1. So review factoring polys. When A is not 1. So the harder ones. And then tomorrow, we should be ready to go to take the test. Now, before we do this, we only talked about those shortcuts, the difference of squares, and the perfect square. We only did that one time so far, I think, on Monday. So let's go over that together real quick. And then I just want to do practice problems with you until everyone is ready to blow that post test out of the water. So, difference of squares first. Let's review that. Difference of squares. Difference means minus, subtraction. Squares means something being squared, some number being squared. So, like x squared, or 16, or 25, or 36, any squared numbers. So, what we're looking for is problems that will look like this. Here's example 1, x squared minus 81. So your first red flag is this doesn't look like a normal polynomial, right? It's missing the middle term. It's just two terms, x squared minus some number. So if you see that, you should be going straight to, oh, this is probably a difference of squares problem. Double check. Are both of these things squared numbers? X squared it's x being squared. So that's squared. And 81, if you don't recognize it, try it in your calculator. Do the square root of 81. And yes, it comes out to 9. So 80, just my logic is 81 is equal to 9 squared. And that's what we're trying to confirm. Is this some number squared? Yeah, this is 9 squared. So how do we simplify this? How do we factor this fast? As long as it's a subtraction of two squared numbers, then it simplifies to x plus 9, the square root of 81, times x minus 9. X plus the square root, x minus the square root of whatever the 81 term is, the C term. Remember, this is basically the C number, ABC for our polynomial. So it's the square root of C. Any questions or comments on this so far? I talked about this on Monday for the first time. So if anyone missed that day or just forgot about it, this is where that started. Let's try another one like that. So x squared, let's do minus 169. I think that works. All right, I want you to try this one for me. Factor x squared minus 169. So it's equal to x plus something, x minus something. Can you figure this one out for me? And if you do, let me know.
x plus 13 times x minus 13.
Perfect. Thanks, Aaron. How did you know to use 13?
Because that's the square root of 169.
Perfect. Thank you for sharing. So you see a problem like this, x squared minus something. Check to see if that number, the 169, is, if you can take the square root and you get a whole number like 13 or 14 or anything. If you get a whole number, then you can go straight to this as our shortcut. That's the answer. It's factored. If you forget about this rule, then I want you to know that you can factor it using our method, our 6 steps that we've been doing for factoring. If we did it like that, then I'm not going to do the whole thing, but I'm just going to start it to show you what it would look like. Find A, B, and C. A is 1. B is 0. Because there's no x term in the middle, it's like saying 0x. So B is 0. And then C is negative 169. And then you're making your list, multiplies to A times C, remember? And that's going to be negative 169. And then check that against things that add to 0, because that's our B. And then you would go down the list, 1 times 169, okay, 2 doesn't work, 3 probably works, check and see, 4 probably won't work. You're going to make your list all the way until you find basically the match. And I think what it's going to come to is 13 and 13. 13 times 13 is 169. And if you make one of them negative, then when you add them, you get the 0. Check. And there's our setup. So then you were factoring it like this. X squared minus, this is a weird thing, right? Because there's no X term or B term in the middle that we're splitting up. But technically, we're going to put it in there like this, negative 13x plus 13x. That's what we found in our list. Minus 169, and then we're doing our factoring, and we're going to end up with x plus 13, x minus 13. Okay, really quick. I want to see thumbs on using the difference of squares, not on doing the whole process for it, like I started below, just on using the shortcut. How do people feel about seeing a problem like x squared minus 169 and factoring it to what Aaron did, x plus 13, x minus 13? Are we ready to move on from this, or should we do some more? Alasia, thank you. Manaya, thank you. How's everyone else feeling? Delaney, thank you. Aaron, thank you. Sai, appreciate it. Thank you. Hunter, Janessa, Bailey, how you guys doing? Oh, chat messages, of course. Bailey, thank you. And Janessa, awesome. Okay. All right, folks. Then let's look again really quick at the perfect square. This one's a little trickier, at least for me it is. It's not as intuitive. So this is the second shortcut we learned, perfect square. Shortcut. Okay, so in these situations, we're given a polynomial, told to factor it, just like normal, x squared plus 14x plus 49. So frankly, if you're given this, you might not be thinking, oh God, is this a perfect square problem? I don't know. If you just start factoring it like normal, it'll still work. You'll still find the answer at the end. However, if you notice that if C is a perfect square, just like the perfect squares we had last time, like x squared and 169, 16, those are square numbers. So if C is a square number, like 49 is 7 squared. And then you check B. If B is double the square root of C, then this whole thing factors to x plus 7, the square root of c, squared. It's x plus 7 times x plus 7. So we're checking to see, okay, is c a perfect square? Is it something squared? If it is, check b. Is that double whatever the square root of c is? And then if so, we can just go right to the end. X plus 7 squared, done. And like last time, if you go through the whole process with this instead, it'll work that way as well. You'll find 7 times 7, you'll split up 14x as 7x, 7x, and you're done. Let me do another quick poll. Would folks like to do, like me, to go through more of these? Would you like to get more practice with these perfect squares right now? Thumbs up if you're good and you don't really want to do more of these formally. Sideways is like, let's do some more practice. Okay, Manaya, I see that. Thank you. Remember, everybody, you don't have to give me a thumbs up. I just want to know where you're at. I want to gauge where everyone's at with this. All right, Aaron Delaney, thank you both. Aaron Delaney. All right, anyone else? You guys are good? All right. Braden, how you doing? Do you have any questions or comments right now? Perfect square or difference of squares?
No, right now, no.
Okay. Well then, folks, we've got about 40 minutes left, so I'm going to give you some problems. I want everyone to try them. I want to see your notes at the end of today, so follow along and do these problems with me. This is our practice. This is our review for the unit, just like we were doing yesterday. So now I'm not going to tell you if it's a difference of squares or if it's a perfect square. I just want you to try solving it, and then we'll talk about what you get, okay? So what's number are we on? I guess example 3 here. And I want you to try.
Example 4.
Oh, go ahead. This is number 4?
Yeah.
Thanks,
sorry.
Leisure. No, I'm sorry to cut you off. Thank you. Number 4. All right. So I don't think we've done this yet. 30x squared minus 5x minus 10. The hint I want to give you is if a is not 1, like this time it isn't, can you start by dividing anything out of it that you could divide from all the terms, like 2 or 3 or 5 or something? That will help with the rest of the problem, give you smaller numbers to work with. So factor this, please. I want to give you a few minutes. So if you get an answer, don't just shout it out to me. Just give me a heads up and say, I think I've solved it, or I have a question. And then when I get a few people who have finished it, we'll talk about it and move on to another one, okay?
I don't know if it's right, but I think I have an answer.
Awesome, Aaron. Thank you. Just hold tight. Let's see if we get 1 or 2 more people finished in the next few minutes, and then I want to hear from both of you, okay? I just had another idea. Aaron, can you tell me what your first step was? Maybe this might help if anyone else is wondering how to get started. What was your first step, Aaron?
You said that you could like see if you could divide a number by all of them.
Mm-hmm.
So I divided 5 by 35 and 10.
Beautiful. Okay. So when you do that, we are dividing it, but we have to keep track of what we divided out. We're factoring out the 5. So you got this probably, or
Yeah.
something else. Okay, cool. I'm going to stop there for now, and I want to see if other people can finish. And remember, you don't have to tell me your answer, everybody. I just want to know if you finished or have a question on where to go next. Okay. Does anyone need more time? Is anyone working on this problem besides Aaron?
Yeah, I'm still working on it.
Okay, Braden, thank you for responding. Keep working. Do you have any questions, Braden?
Um,
Do you feel in control right now, or do you need a hint on like what to do next, maybe on a stage you're at?
yeah, I'm gonna be honest. Yeah, I'm not too.
It's okay.
Uh,
It's okay. Honesty, I totally appreciate that. Can you tell me what you have so far? Would you mind?
um, I'm still on the first step because you told me the hint, but I'm not. So I'm just not understanding.
It's okay. Can you see my screen right now or no?
Yeah, I can see it. I see you're on the second step, but like I didn't want to move to the second step without knowing, what to do.
Okay. So, no, I appreciate your honesty. I really do. Um, Thank you for taking that risk and saying that. So, what Aaron did is, and using that hint, I was trying to be sly with a hint, but maybe it didn't make sense. Is check first to see if these coefficients, 30, -5, -10, if those can be, if we can pull out a GCF, a common factor, some number that is divisible through all of those, then it'll make the numbers a little smaller. And then what we have to factor for our polynomial is a little easier. So I look at the numbers 30. Okay, well, I could cut that in half. 10, I could cut in half, but we can't cut 5 in half. So we can't divide by 2. Maybe 3. I could divide 30 by 3, but 5 doesn't work. 10 doesn't work. But then you get to 5. And that's what Aaron found. And you can divide all these numbers by 5. So start by pulling out the 5, so to speak. We're factoring out 5. We're literally factoring out the 5. And that's why we see it out here of the parentheses. 5 times all the remaining stuff. 6x squared minus x minus 2.
Oh, okay.
Is that okay so far?
Yeah, so on something like this, so we just divided it to something more reasonable.
Where you divide exactly.
Only if it works.
If it works, exactly. That's exactly right.
Thank you. That was so much.
Does that help?
way better. Yeah.
Okay. And then now I want you to look at it as like, okay, cool. I can't divide out anything else here that would be more reasonable. So now I'm going to call these the A, the B, and the C, and we start that whole process. So A is 6, B is -1, because there's no number there with X, but it's negative. So -1, and C is -2. And we start our lists. Find the two numbers that multiply to make, well, 6 times -2, A times C. Remember that. Multiply to A times C. So that's 6 times -2. But those aren't the ones we're splitting it up as. We have to find what that larger number is. It's -12. And there might be some other mix of two numbers that make the -12 that add to -1, the B. And we're going from there. I want to give other people a chance to try this problem. This is a good example of something that we'll see on the test. So keep working, and if anyone wants to ask for a question or a hint, or just tell me you tried, you finished it, and you have an answer, let me know, please. Aaron, are you still there? I want to give you a different problem to work on since you're waiting. If that's cool.
Yeah, I'm still here.
Okay. I'm going to go to another screen real quick. Here, for Aaron, try this one. Start this one, please. 64x squared minus 48x plus 9. Copy that down, try factoring that, and then I'm going to go back to the other question while people are still working.
All right.
Okay. So for people still working on number 4, did anyone at least make a list of numbers that multiply to make -12 or 12?
No, I'm on that part.
Okay.
Yeah,
So
that was a little confusing for me too.
Braden, do you mind if I work on this with you? Is that cool?
Yeah.
So start with like this. The number's 12 basically, right? We're looking for numbers that multiply to 12. So I'm going to start with 1 times 12. We rarely ever even use that option, but it helps me organize this list I'm making. 1 times 12, and then I want to see, can I do 2? Here, Braden, look at this. Here's how I'm really thinking about it. 1 times something, 2 times something, 3, 4. I'm basically going to go from 1 upwards, like counting to higher numbers. And are there numbers that I can multiply to make that 12? And if 12 is a pretty small one, right? If we had a larger number like 140 or something, then this list will be even longer. But they don't always work. So 1 times 12 works, that's 12. 2 times 6 works. And to find these out, use your calculator and just divide. How I'm doing it is I'm going 12 divided by 2, that's 6. 12 divided by 3, that's 4. And then 12 divided by 4 is 3. And once the list starts to repeat, we can stop. We don't really need to show all the rest because it's going to be 6 times 2 and 12 times 1.
Oh, okay.
Does that help?
Yeah, that helps because I was actually really confused on that list part.
I'm sorry. I didn't mean to make anyone feel or leave anyone behind on this. When I always am talking about make your lists, what I mean is start by doing 1 times the number, which is 12 in this case, and then just start going up from there, like 2 times something, 3 times something. Sometimes they don't work. Like, well, for instance, 5. I didn't put that in my list here. 5 doesn't work. 12 divided by 5 is 2.4. So we don't even bother with that. I'm going to cross that out. We just want the whole numbers. And then from here, we're checking to see which mix of these numbers, if one of them is negative, gives me a -1 when we add them. So, for me, the fastest way to think about this is like just subtract the space between the numbers we found. So 1 and 12, how much space is there? 11, right? So if I make that -1 and +12 or -12 and +1, either way, we're going to get an 11, +11, -11. We don't want that. We want a -1. So it's not going to be that configuration. Then we move on, and I'm basically, and maybe you've seen it already, the only mix here that has a 1 in between them, a space of 1, is 3 and 4. So it's going to be that one. Which one should be negative? Well, which one would I want to make negative so that when we add them, we get a -1 answer? So if the 3 is negative, -3 plus 4, that's +1. Well, we want negative, so it has to be 3 minus 4. This one here. So +3 and -4. And now what do we do with that once we find it? This whole list we've made, what's the point? Why are we doing this? We're doing this so that we can find out how to split up our middle term. So going back to the actual polynomial in the middle.
So then we put the 3x and the -4x where the x was?
Correct.
Okay.
Absolutely, sir. Yes. Bring down the a and the c parts. Those don't change. But like you said, the 3x, -4x replaces whatever we had for the middle, -x. Plus 3x minus 4x. Good. Okay, Braden, keep going with me. So now at this point, we look at the first 2 terms, and separately, we look at the last 2 terms. So for us, that's the 6x squared plus 3x. So for the first 2 terms, what can I divide out of there? Can I pull out any number? Can I divide out a whole number from both of those?
What you said, we got to divide one of them out.
Yes, we're asking at this stage, we want to find out, is there any number we could divide out from 6 and from 3? Because those are the numbers there.
Yes.
Yes, sir, we can. Can I divide 2 from both of those? Like 6 divided by 2, that works. But 3 divided by 2?
Nah.
No, we can't do that. And if you're iffy on it, try it in your calculator. 3 divided by 2, it gives me 1.5. That's garbage. I don't want that. So 3, though, does work. 6 divided by 3 and 3 divided by 3. So that's the question we're asking ourselves. Is there a number I could divide out of both of these terms? And I found it's 3. So I'm going to divide 3 out from those first two terms. And also, Braden, the x's. We're always going to have a single x we could divide out of the first two terms. So notice that we've got like x squared and then x. And each of those has at least one x. So I can divide out 3x from the first two terms. Or I should say factor out 3x from the first two terms. So when we do that, what's left over in those first two terms? Here, I'll show that over on the right, that like work, the logic that's happening there. 6x squared divided by 3x. Well, now we're using the unit 1 approaches that we were doing. So 6 over 3 is 2, and x squared over x is just x. So that's what's left from my 6x squared. 3x divided by 3x, well, that's just 1 because it's something divided by the same exact thing. So 2x plus 1 is left over.
Okay.
You with me still?
Yeah. Sorry,
Okay.
I was writing.
Don't be sorry. It's okay. I just want to check. Am I going too fast?
No, that's perfect.
Now, do you remember we're going to do the same thing over with the last two set of numbers, the 4x minus 2. But and when we do it, we want to see the leftover parentheses match what we just found for the first one. So we're hoping it's going to be 2x plus 1. So, but we ask the same questions. What do we divide out from -4 and what can we divide out from -2? The highest number that we could divide out from both of those.
Could we do 4 divided by 2?
Yes, and 2 divided by 2.
Oh.
Right? We can take a 2 from both of those. We can divide 2 from both of those. So, and not only that, Braden, we're going to pull out, because these are both negative numbers, we're going to pull out -2. So not just the whole number +2, but make it negative. Since these are both negative, make what we're dividing out negative. So we're going to pull out -2. We have to keep track of what's still there. So I'm going to make my parentheses ready to go. So negative, and I'll do the side work. So -4x divided by -2. The whole number portion, -4 over -2 is just +2, and x is still there. It doesn't go away. It can't cancel or divide, so it's still there. So we have 2x. And then -2 divided by -2, is 1. And so lucky us, we get the matching parentheses just like we were hoping for. And now our final step. This is, I think, the easy part, but it, is a lot of work to get here. Now we factor out the 2x plus 1s because we've got 3x times the parentheses minus 2 times the same parentheses. So what we're doing is we're factoring out that whole parentheses, and it doesn't matter which side we write it on. So I'll write it first here, 2x plus 1 times the leftovers, 3x minus 2. Maybe I should have built up to this problem instead. I've got some other ones here that might have been a tad easier to start with. But you know what? This is a good problem. I do want everyone to be able to eventually do this kind of problem question totally confidently. But I know it's not easy, and that's a lot of work. So that's why practice is going to be our best friend here. Not just for you. I'm not talking to you. I'm talking to everybody. So we're finally done. We've got 5 times 2x plus 1 times 3x minus 2.
Thank you. This helped a lot.
Absolutely. Any questions, any comments, or anything you noticed?
Not right now, no.
Okay. Anyone else? Questions, comments, concerns? I want to check in really quick with Aaron. Aaron, did you finish the second question I gave you?
Yeah, I think so.
What'd you get for that? Would you mind sharing?
8x minus 3 in parentheses to the second power
Okay, squared. Okay.
or
Would
square.
yeah. Either way is good. To the second power. You're right. So, if you don't mind, I'm going to go through this one, and I want people to. I'm just going to go through this one. So, we're starting at the top, and we're going to check and see. I think Aaron is correct. Good job, Aaron. But let's just see how she got that. So we have this polynomial. Okay, we've got these huge numbers for A, B, and C. Unfortunately, we've got 64, minus 48, and 9. So if we start this off with our lists, we would say what multiplies to 64 times 9. And let me tell you, this is going to be huge. It's 576. So that list we make is going to be a nightmare. Frankly, it's going to be way too much work. So I'm going to back up a little bit and say, can I divide anything out of here? I could divide 3 from 9. I recognize that one. And then check to see if I can divide 3 from 64. I can't. When I do 64 divided by 3, I get a decimal. So I can't do that. I can't divide 2 from 9, even though the other two numbers are even. So it's like I'm striking out on dividing something out of this problem. However, I also noticed that C is a square number. And for the first term, my A term is 64. That's 8 squared. And then x squared, of course, is a square number, right? So this is a square number. This is a square number. This might be an example of the perfect square, which we can use as a faster shortcut. So what's this? Oh, but then again, our A number is not just x squared, is it? So that's going to be a little bit of an issue. So you know what? I guess we do need to make our list for this. Let's see. If we went about it with the perfect square, I see. Okay. The square root of 9 is 3. So ideally, it would be like x plus 3 squared, but it's not going to work like that because we've got the 64. It's got a square root we're dealing with as well. Its square root is 8. And then I notice, okay, 8 times 3 is 24. And double 24 is magically, lo and behold, the 48, the B number in the middle. So this is a perfect square, but it is going to be a little trickier to use the perfect square rule when A is not 1 itself. So let's try doing this with our lists. Same problem. Okay, so 64 times 9. So we're making our lists. Multiplies to A times C. That's 64 times 9, which is 576. So even though it's a huge number, and it is intimidating, even to me, I'm just going to start it like I was doing in the last example. We want to find the pair of numbers that adds to make a negative 48. The B value. All right, so here's how we start. 1 times 576. Okay, it's not going to be that one. Now I'm going to set it up like this. So 2 times, 3 times, 4 times, just make a few of them there, and we'll probably go past that. But let's see what we get. So 576 divided by 2 is 288. But the difference between 2 and 288 is huge, right? It's 286. So it's too big. We're looking for it to be closer to 48. So that won't work. Divide by 3. 192. Cool. It came out even, but still too big, right? So we're going to have to find some that are probably closer to the middle of our list. 576 divided by 4 is 144. 5's not going to work. 576 divided by 5 is a decimal, so I'm going to cross that out. 576 divided by 6 is 96. We're getting closer. Smaller numbers. That's good. But it's still too big, so check the rest. 7 times, 8 times, 9 times. And what I'm doing is dividing 576 by all these numbers, these 7, 6, 8, 9. 7 doesn't work. Cross it out. 8 worked. 72. 72 minus 8 is 64. So we're looking for the space between to be 48. Or also, the sum of them could be 48. Now, why is that? Because they're multiplying to make a positive 576, but they add to a negative. So that means they're probably both negative numbers. So we actually want to see the one that makes the sum, because it's going to be like -9 times negative something, positive 576. 72. Okay, so 9 and 64. So notice that in my list of numbers I'm making, the numbers on the left are increasing, right? 1, 2, 3, 4, 5. The numbers on the right are decreasing. So they're kind of meeting in the middle. So I'm not sure what it's going to be, but somewhere in the middle is where we're going to find the ones we want. So 10's not going to work. 11's not going to work. 576 divided by 12. So I got 12 times 48. Interesting. 576 divided by 13. No. Okay, I got 576 divided by 16 is 36. So 16 plus 36 is 52. So that's just not going to work. Keep looking. 576 divided by 17. 576 divided by 18. 18 worked. 18 and 32. It's closer. The sum of those is 50. So if I was testing this out, -18 minus 32 comes to -50, and see how close that is to -48? So that means we're on the right track here. So let's try the next one. Can I divide it by 19? 576 divided by 19. Nope. By 20. No. 21 didn't work. Oh my goodness. Okay, so I finally got it. I think 24 and 24. Okay, so look, this is a good example because it's not always fast and easy. Sometimes the lists we make is going to be humongous, like this one was. So -24 times -24, that's probably our answer. They multiply to make 576, and when we add them, they add up to 48 or -48. So now we split up our middle term like we did earlier. So we're back to the actual problem now, right? We've done our homework and now we're ready to do the actual work. -24x, -24x plus 9. Now, most of the problems that I've seen from the test and from like our mastery test and stuff actually aren't this bad, but or this hard to find. But it's good to see it. It's good to know. It can be kind of crazy to make those lists. Anyways, now we isolate the first two and the second two, and we want to factor out what we can from each. Okay. Can I divide out a straight up 24 from both of those terms? I don't think so. No. I can divide out 8 from both of these terms. I can divide out 8x. Remember, you're always going to be pulling out an x from the first two terms. And I've got 8 divided out as well. So that's 8x minus 3. Now, how did I find that? Side work. 64x squared divided by 8x is 8x. And then 24x, or negative 24x, divided by 8x gives me negative 3, and the x's canceled. Okay. Now on the right side, I can pull out 3 from 9 and from 24. So let's do that. And then another thing, folks, is notice that the signs aren't the way we want them. 24 is negative, 9 is positive. So I'm going to divide out a negative 3. And then we continue. So we get 8x minus 3. And now we've got our matching parentheses. Cool. So pull that out. 8x minus 3. In the leftovers, and this is actually a perfect square. 8x minus 3 to the second power, which is what Aaron had, I think. Yep. So the shortcut does work, but when we have a number here for A, the 64, then that's got to be taken into account as well. So the square root of that, square root of C, when those are multiplied together, we're looking for the middle term is that double those multiplied together. So the perfect square rule would apply here, and it would have made it a lot faster, but I also want you to be able to find it the longer way. All right, we didn't do too much today. We only did, I guess, 5 problems. But we had some good conversations, so I hope that was helpful for everybody. I guess I'm not going to issue any more homework. We've already got homework to do. So I want you to spend today trying to finish up any mastery tests that you haven't done. We should have all the mastery tests in Unit 2 complete. All the mastery tests in Unit 2. It's only like 4 of them, I think. Small. And then the 2 questions, 2 different days of questions. I texted that out and I emailed it out. So spend your time today catching up on that. Tomorrow we're going to do a test. I think it's a shorter test, 16 questions. So it's not too bad. Could be worse. And we'll do that tomorrow as a group and have in Unit 2 of math. All right, if people are still there with me and haven't completely checked out yet, can I see your notes? So I'm going to mark you down for participation. Then you can go for the day.